So this is my predicted paper for paper 2 on the 3rd of June. This is the calculator paper for Edexcel Foundation. So hopefully you enjoy it. I've looked at all the topics that came up on paper 1 and used that to help me predict what I think will happen on paper 2. So here we go. Question number 1, write down the value of the 5 in the number 3,507. So the 5 is in the hundreds column. And so we're going to say 500. If you just write hundreds, you're not going to get the mark there. So you either need to write 500 or 500s. You can write that as well. That's absolutely fine. That's the value of that 5. Question number 2, write 32% as a fraction. Give your answer in its simplest form. So 32% means 32 out of 100. And we can write that as a fraction like this, but we've got to write it in its simplest form. So you think, what times table are 32 and 100 both in? Now they are both even, so I can divide by 2. There is a slightly bigger number, but let's say we divided by 2, 16 over 50, and those numbers are both even, so we can divide the numerator and the denominator by 2 again, and that is 8 over 25. Now there's no number, no factor that is common to both of those, so that's as far as we can simplify it. So 8 over 25 would be your answer there. Question number 3, change 4 metres into centimetres. So we know that 1 metre is 100 centimetres. So if I want to go from metres to centimetres, I would be multiplying by 100. And if I was going from centimetres to metres, I'd be dividing by 100. Here we're going from metres into centimetres, so that's going to be timesing by 100. So 400 would be my answer there. For question number 4, write down the first even multiple of 9. So multiples of 9 are numbers in the 9 times table. If you think about all the numbers in the 9 times table, there we go. The first even one is going to be 18. 9 is odd, 18 is even. It's even if it's in the 2 times table. So there we go, 18 for that one. Question number 5, solve x, subtract 5 equals minus 2. When we're solving equations, we want to put a dotted line where the equals is, and remember that what we do to one side we're going to do to the other. I would like to know what x is, so I'd like to get that x on its own. Now in order to get x on its own, I need to get rid of the minus 5. Getting rid of minus 5, we're going to do the opposite, so I'm going to add 5 to this side, but if I've done that to that side, I also need to add 5 to this side. Think about your number line. If you're at minus 2 and you add 5, you're going to go up, you're going to go past 0, and you would get to 3. So x equals 3 would be your answer, therefore 1 mark. Question number 6. Here is a list of numbers, 8, 20, 23, 25 and 32. From the list, write down a factor of 16. Factor of 16, I'm going to write down 8. 8 fits into 16 2 whole times. So if it fits in a whole number of times, that is going to be a factor. Don't write 32. 32 would be a multiple of 16 because it's in the 16 times table. So that's not what we're looking for here. For part B, we need to write down a prime number. Now a prime number is a number that has 2 factors, 1 and itself. So I'm looking for a number that is only in the 1 times table and its own times table, and that's going to be 23. 23 has no factors other than 1 in itself. So 23 is prime. All the other numbers are not prime. So that's your only answer that you can have there. And for part C, a cube number. Now a cube number, 1 times 1 times 1 is 1. 2 times 2 times 2 is 8. 3 times 3 times 3 is 27. And just so we do the first few, 4 times 4 times 4 is 64. So in terms of a cube number, it's going to be the answer. So 8, we can see 8 is there. So 8 is our cube number that's in the list. There we go. Question number 7. Nikki is buying a camper van. The camper van costs £24,000 plus VAT at 20%. Nikki pays a deposit of £7,000. She then pays the rest of the cost in 40 equal monthly payments. How much is each monthly payment? So first let's work out the cost of the camper van. It's £24,000 and an extra 20% needs to be added on top. Now there's a couple of different ways you can do that. 10% we would get by dividing by 10. So that would be 2,400. And so 20% is double that, which is 4,800. So we need to add that on top. So add 4,800 to that, 0, 0, 8, 8, 2. So 28,800 is the cost of the camper van. Now, instead of it doing that way, if you want 120%, you can also multiply by 1.2. That gets you straight to 100% because 120% because 120% as a decimal is 1.2. So if you wanted to, you could do 24,000 times 1.2. That would also get you straight to that answer of £28,800. So that's the cost of the camper van. But she's going to pay 7,000 up front. So we're going to take that off. We've paid that. She's walked in to that camper van store and said, right, I'm going to give you £7,000 today. That's what a deposit is. 8 take 0 is 8. 8 take 7 is 1. And 2 take 0 is 2. So we now know that she has £21,800 left to pay on that camper van. And she's going to pay that in 40 equal monthly payments. So we're now going to do 21,800 and we're going to divide that by 40. Now we do have a calculator for this. So I'm just going to type that in my calculator, 21,800 divided by 40, and that gives me an answer of £545 for each of the months. There we go. Question number 8. Simplify 3 times m times 7 times p. Well, I can multiply 3 times 7 to be 21. And then when we multiply with algebra, we just write the letters next to each other. So 21 m p. You could put pm. It's still not going to be wrong, but we tend to go in alphabetical order. So 21 mp would be the best answer there. Simplify t times t times t. Now when we multiply, that's going to increase the power. So t times t is t squared. When we times that by another t, we get t cubed. Please don't confuse that with t add t add t. That would be 3t. But that isn't what we've got here, okay? So it's going to be t cubed instead. And then for part C, or that should say B, that should say C. Simplify 3n squared, add another 3n squared. Well, they're both n squared, so we can collect them up. It's going to be 6 lots of n squared. The power is not going to go up because we're not multiplying. If you're doing n squared times another n squared, that would be n to the power of 4. But here we're just collecting them up. We're saying I've got 3 lots of n squared and another 3 lots of n squared. So altogether I've got 6 lots of n squared. There we go. Question number 9. Work out the value of 2.4 add 3.1 squared all over the square root of 1.087. So this is testing your ability to put this in your calculator. Now I'm going to use my fraction button first. So I'm going to press that button first to get this as a fraction. And in the top I'm typing 2.4 add 3.1 squared. And then I'm using that down arrow on my calculator to come down to the bottom of the fraction. Then we're going to press the square root button, 1.087. Hit equals, and for that I get 11.51935693. And we're asked to write down all the digits on our calculator display. For part B, write your answer to part A, correct to 2 decimal places. So we've got one number there after the decimal point and a second number. Then we're going to check the next number, which is a 9, so it rounds up. 11.52 is your answer there. Question number 10. His home at 8 a.m. and walked to the supermarket. The supermarket is 2.5 miles from his home. He got to the supermarket at 8:40 a.m. Work out the average speed Neil was walking at. So we've got speed, distance, time for this. And if we want the speed, cover that up. It's going to be distance divided by time. So the distance we know is 2.5. So we're going to do 2.5 divided by the time. Now the time was from 8 a.m. to 8:40, so that's 40 minutes. Now what I would do here, you can divide by 40, but the problem is that's not going to be in miles per hour, that's going to be in miles per minute. So you're then going to need to multiply your answer by 60 at the end to get it back into miles per hour, and you can do that, that's absolutely fine. The alternative is to get that 40 minutes in hours, and 40 minutes as in hours is 40 out of 60. So you can just also do it like that. Either of those methods will be absolutely fine. But just remember, if you're doing miles per hour, you want to do miles divided by hours, and it's 40 minutes out of 60. That is what fraction of an hour you've got, and that gives me an answer of 3.75. So 3.75 miles per hour there. For part B, Neil spent 38 minutes in the supermarket and then he walked home. He took 50 minutes to walk home. At what time did Neil get home? So it's 38 minutes in the supermarket. He got there at 8:40. We've got that from the question at the top. 38 minutes in the supermarket and then 50 minutes to get home. So if I go 38 minutes, first thing I like to do is go to the hour. So it's going to take me 20 minutes to get to 9 o'clock. And then it would be another 18 minutes so that I've added 38 altogether. So 9:18, he's done in the supermarket. We then need to add another 50 minutes. And I'm going to split that again. And I'm going to say, right, to get to 10 o'clock, there are 60 minutes in an hour. I'm already at 18. So that's going to be another 42 to get to 10 o'clock. And then I would just have 8 more minutes. So 10:08. I'm going to put AM just so we're really clear about the answer. 10:08 AM is what time he would get home. Question number 11. There are 400 stickers for sale in a store. Sally buys 4/5 of the stickers. Sally then gives 3/8 of her stickers to Shona. Write the number of stickers Sally now has to the number of stickers Shona has. Give your answer in the form n to 1. So there were 400 to begin with and Sally bought 4/5. So we need to do 4/5 of 400. Now in your calculator you can type 4/5 times 400. That would get you the answer straight away. Or we know that when we do a fraction of a number, we divide by the bottom, get that answer and multiply it by the top. So 400 divided by 5 is 80 and 80 times 4 is 320. So either way there would be fine. So she's got 320 stickers. But then she gives 3/8 of her stickers. So 3/8 of this to Shona. So now we need to do 3/8 of 320. And again, we can divide by the bottom and then multiply that answer by the top. Or we can do 3/8 times 320. Either way is fine. I'm going to divide by the bottom, which is 40. And then times that by 3, which is 120. So Shona now has, we've got to write as a ratio. So Sally to Shona. Shona's now got 120. Sally has 200 because she's given 120 of these to Shona. So if we take that away from 320, she's left with 200 and Shona now has 120. Now we need to write our answer. This ratio needs to be something to 1. Now, if you want this side to be 1, we're going to need to divide by 120. And if we're dividing this side by 120, we're also going to need to divide the other side by 120. So 200 to 120, 200 divided by 120 is 1.6 recurring. So it's 1.6 recurring to 1. That would be your final answer there for 2 marks. 1.6 recurring to 1. Okay, fabulous. Question number 12, work out 46% of 240. So 2 ways of doing this. We can say 10% would be 24. To get 10%, we divide by 10. So another 10% is another 24, another 10% is another 24, and another 10% is another 24. You might find it easier to add it up like that, or you could times it by 4. We then need 5%, which would be half of that. So that would be 12, and 1%. Now, to get from 10% to 1%, you're dividing by 10 again, so 2.4. And you could add all of that together, and that would get you 46%. The other way to do it is to get 46% as a decimal, which is 0.46, and multiply it by 240. So that's going to be a lot easier in this case because we have a calculator. 240 multiplied by 0.46, and that is going to be 110.4. And we'd get the same answer if we added all of that up, but a little bit easier just to use the decimal multiplier, I think. Okay, question number 13. Describe fully the single transformation that maps triangle A onto triangle B. So we need to say what this is. Now there are 4 transformations. We can have reflection, rotation, enlargement, or translation. Now reflection is when there is a mirror image. Rotation is when it's turned. Enlargement, it would be bigger or smaller. And translation is when it's just moved, but it's in the same orientation. Hopefully you can see that this is a reflection. If I draw a line here, this would be my mirror line. And we're 2 squares away on the left, so it'd be 2 squares away on the right. So we need to say that it is a reflection in the line, now we need to say what this line is called. This line goes through -1 on the x-axis. So that is the line x equals -1. Any line going this way is x equals the number it goes through. And any line going this way, for example, this line would be y equals 2 because it goes through 2 on the y-axis. So just in case that comes up, reflection in the line x equals -1 would be your answer there. Okay, question number 14. 65 students from year 10 and year 11 are asked how they usually travel to school. 35 students are in year 10, so we know that this number here is 35. We've got 65 students altogether in the total. 10 of the 28 students who usually walk are in year 11. So 28 students who usually walk, and 10 of them are in year 11. 12 year 10 students cycle, and 19 students get the bus. So filling in all of that looks like this. So now I know that this one must be 18, because 18 and 10 makes 28. And then going across here, 18 add 12 is 30, so there must be 5 students getting the bus. And then bus we know is 19 students, so there'll be 14 more here to add that up. And then let's have a look at this one. What am I missing? 28 add 19 is 47. So I need to do 65, take away 47. More on the floor, borrow from next door. I know I could just use a calculator, but there we go. So I've got 6 here. And then this one we know is 30. And let's just double check. If we add these together, we do get 30. So I'm happy that I've done that correctly. Great. One of the year 11 students is chosen at random. Write down the probability that this student usually cycles to school. So we're only picking from year 11 students, and there are 30 year 11 students. So this is going to be out of 30. What's the probability they cycle to school? 6. There are 6 year 11s that cycle to school out of 30 year 11s. If I said I'm going to pick a student at random, then it's going to be out of 65. But if I'm only picking from the year 11s, then it's out of 30. Part C, what is the modal method of travelling to school? So what is the most common method of travelling to school? The mode is the most. So looking at all of those, we can see that 28 students walk, 19 get the bus, and 18 cycle. So 28 is going to be the highest frequency there. So walk is going to be our modal method of travelling to school. Question number 15. The scatter graph shows information about the number of likes and shares of 10 different posts to a social media account. So we've got number of likes on the y-axis and number of shares on the x-axis. It says one of the points is an outlier. Write down the coordinates of this point. So an outlier is a point that does not fit the trend of the data. And we can see that the data is following a pattern over here like this. This point here does not fit the trend of the data, and so we would say that that is an outlier. Now be really careful when you're reading off the axes. I've been quite crafty here. I've gone 26, 27, 28, 29. So this is going to be 28, and then in this direction we can see that that is 30. So 28, 30, remember, along the corridor, up the stairs, that's going to be how you read the coordinates of that outlier. For part B, for all the other points, write down the type of correlation. Correlation is either positive or negative. In this case, the pattern is going up. The more likes the post receives, the more shares the post receives. So positive correlation there. You can put weak or strong, it won't make a difference, as that word positive is what's going to get you the mark there. And then for part C, the same account makes an 11th post which had 72 likes. Estimate the number of shares this post had. So we're going to use our line of best fit here. If it had 72 likes, we're going to go to 72 on this axis, go across, hit the graph, and then go down. And I get 8 for that. I think 8 or 9 there, you'd be absolutely fine. So I'm going to go with 8, but I think I also got 9 when I did this paper earlier. So 8 or 9 there would be all good. Question number 2, write 612 as a product of its prime factors. Give your answer in index form. So we start with 612 at the top, and we need 2 numbers that multiply together to give 612. I'm going to go for 306 multiplied by 2. So I've halved it there to get that. Now 306 is in the 3 times table. I can tell because 3 add 0 add 6 makes 9, and 9 is in the 3 times table. So I'm going to divide it by 3, and that is 102. You can use your bus stop method if you're not sure. 102, that's half it. Let's go 51 times 2, and then 51 is 17 times 3. Again, if you can spot that it's in the 3 times table, use the bus stop method to divide by 3 and work out what's left. All of those numbers that are circled are prime numbers. So now we're going to write our answer as 2 times 2 times 3 times 3 times 17. Those are all our prime numbers there being circled, all our prime numbers that are circled being multiplied together, and that would make 612. Now, to get full marks here, we need to give our answer in index form. So we're going to write 2 squared times 3 squared times 17. You don't always get that second line, but if you do, you need to write the powers. Okay, question number 3. Write 0.0409 in standard form. Standard form is writing a number as a number between 1 and 10 times 10 to the power of something. So I need these digits, so 4.09. Always for standard form, we're putting times 10 to the power of something. Now, if it's smaller than 4.09, we need to do a power that is negative. So if I need to, which here I've got 4 here, and I've gone into the tenths column, into the hundredths column. So I've divided by 10, divided by 10. And that's the same as timesing by 10 to the power of negative 2. So if you're dividing by 10 twice, it's the same as timesing by 10 to the power of minus 2. So a really, really small number is going to have that negative power. For part B, write 2.38 times 10 to the power of 7 as an ordinary number. So this time we're timesing by 10, timesing by 10, timesing by 10, 7 times. So 2.38. If I times by 10 once, I'm going to get 23.8, times by 10 again, and then I've got 5 more jumps. So I'm going to fill in those gaps with zeros, and my answer here would be 238,000,000, which is 23,800,000. For part C, it says work out the value of 1.4 times 10 to the power of minus 5 divided by 2.7 times 10 to the power of 2. Give your answer in standard form, correct to 3 significant figures. Now for this, we're just going to use our calculator. I'm actually writing that first number on the top of the fraction. I just think it's a little bit easier to make sure that it does the correct order of operations. 2.7 times 10 to the power of 2. So using my calculator, I'm typing that in, 2.7 times 10 to the power of 2, and that gives me an answer of 5.185185 times 10 to the power of minus 8. Now, my calculator has given that to me in standard form, but I do need to round it correct to 3 significant figures. So for significant figures, we are starting counting from the beginning of the number. So 5, and then 1, and then 8. And we check the next number. Because it's a 5, it rounds up. So my answer here is going to be 5.19 times 10 to the power of minus 8. For question number 4, a number h is rounded to 1 decimal place. The result is 2.1. Write down the error interval for h. So an error interval is going to show us the smallest and the biggest the value could have been before it was rounded. If we've rounded to the nearest 1 decimal place, we've rounded to the nearest 0.1. Now we would divide that by 2, which is 0.05, and that is going to tell us how much to go above and how much to go below. So from 2.1, we're going to go 0.05 below and 0.05 above. So that's 2.05 for our lower bound and 2.15 for our upper bound. You might be thinking, well, hang on, 2.15, wouldn't that round up? And that's why we've got the inequality symbol there that's just less than. So we can go up to 2.15. We can't technically equal it exactly, but we can go so infinitely close that we're just going to call that the upper bound. So there we go. Question number 5a, expand and simplify. So we're going to expand out our brackets here. Now I've been a bit sneaky with this second bracket. I've subtracted the whole bracket. Now that's the same as taking away one lot of each of the things in that bracket. So when I expand this here, I've got 8k add 4, because I'm doing 4 lots of 2k and 4 lots of 1, minus k, but this should be an add 2, because I'm subtracting that minus 2, and taking away minus 2 is going to add 2. So overall here, 8k, take away k, that gives me 7k, and then I've got positive 4, add 2, which is positive 6. For part B, we're simplifying 3a to the power of 4b squared times 3a to the power of 4b squared times 3a to the power of 4b squared. We are cubing it, so we're timesing it by itself and then by itself again. Now the 3 times the 3 times the 3, that makes 27. So that 3 is being cubed as you would expect. Now with the other values, you can either look up here and say a power of a power, we times the powers together, or you can look at the fact we've got a to the power of 4, a to the power of 4, a to the power of 4, and we can add those powers together. Either way, we get a to the power of 12 and b to the power of 6 there. Question number 6. These are both right-angled triangles. ADC is a straight line. Work out the length of CD. Give your answer correct to 1 decimal place. I'm going to pop an X here so we know what it is that we're working out. This is what we're being asked for. Now, at the minute, I don't have enough information in this triangle to work out the value of X. So I'm going to start over here in this triangle. I've got the hypotenuse. And I want to know this side here, the opposite. The reason I want to know that side is because that side is in common to both triangles. So if I can work that out, it gives me more information in that triangle on the right. So to work that out, I've got the hypotenuse and I want to know the opposite. So out of SO, cat and TOA, I'm going to use SO. The adjacent is down here and I don't know it and I don't want to know it. So I don't want to use cat or TOA because that involves the adjacent. Now, if I want to know the opposite, cover that up and do the sum that's left behind. So that's going to be sine 37 multiplied by 12.4. Now, again, you're going to type that in your calculator. You don't want to round this. So this isn't my final answer. So I don't want to round it. I just want to keep it exactly as it is. On the paper, I'm going to write a few decimal places, but I'm going to keep it in my calculator just so I keep it nice and exact. That is this side here. So I now know that this side is 7.46 and so on. Looking then at this triangle, I now know this side and I want to know this side. So when you know two sides of a right angled triangle and you want to know the third side, that's going to be Pythagoras. So I'm going to do 9.3 squared, take away this value, 7.46 squared, and then I'm going to square root my answer. Now it's a subtract because you have the hypotenuse, you have the longest side. So I'm going to do 9.3 squared. In my calculator, I'm actually typing minus that answer squared, and then I'm square rooting it, and that gives me an answer of 5.54986. We were told to round it to 1 decimal place. So 5.5 is going to be your final answer for the value of DC or CD. Okay, question number 7. The frequency table gives information about the length of 50 parsnips. Find the class interval that contains the median. So there are 50 parsnips here. This adds up to 50. If we want to know where the median is, remember the median is the middle. If I want to find that middle value, I would add 1 and divide by 2. That tells you the position of the middle piece of data, and that is 25.5. So where is the 25th and where is the 26th piece of data? We want to go in between them. So at the end of this category, I've had 2 of the smallest parsnips. At the end of this category, I'm now up to 7. So I've still not reached that middle value. At the end of this category, if I add on another 15, I get to 22. So I've still not reached the middle value. But by the end of this category, if I add 20, I'd be up to 42. So my 25th and my 26th piece of data fall in this category here. This is the class interval, the category. So we're going to write exactly that on the answer line, 15 to L to 20. There we go. On the grid, draw a frequency polygon for the information in the table. Now, for a frequency polygon, it ends up looking a little bit like a shark fin. So we call her Polly the shark. If you know, you know. I've put that down here. So that was my explanation for that. So Polly the shark, if you have heard me talk about that before, hopefully that's stuck in your head. So we go in the middle of the category. Polly, she lives in the middle of the ocean. So if we've got 0 to 5 and a frequency of 2, then we're going to go up to 2, which would be there. Every 2 squares is 1 in that direction. Watch out for that. So again, we're going to go in the middle of the category. So halfway between 5 and 10, we're going to go to 7.5 and go up to 5. The next category, we're going to go across to 12.5 because that's in the middle of the category there, and up to 15. So that'll be there. Next one is going to be 17.5 and up to 20. And last but not least, we've got 8, and that's going to be at 22.5. So let's go 6, 7, 8. There we go, like that. So be really careful with your axes and checking that it's not going up in 1s or going up in 2s, whatever it's going up in. There we go. So it's not always going to make a perfect shark fin, but it looks like that. The other thing I will say is please do not connect it to the origin. Polly is a shark. She likes to be out at sea. She doesn't want to be anchored to the shore. There we go. I know it's really silly, but hopefully it helps you remember what the graph looks like for a frequency polygon. Polly the shark lives in the middle of the ocean, so we go in the middle of the category. Okay, lovely. Question number 8. The probability tree diagram shows the probabilities that Megan will be late for work on Saturday and on Sunday. Calculate the probability that Megan will be late on exactly one of the 2 days. So we don't mind if Megan is late on Saturday, but then she has to be not late on Sunday. Or she can be not late on Saturday and late on Sunday. So we only want her to be late on one of the days. With a probability tree, we are multiplying along the branches and then adding them up at the end. So for this branch, it would be 0.23 times 0.9. Let's type that in your calculator. 0.23 times 0.9 is going to be 0.207. And for this category, for this branch, 0.77 times 0.12 is going to be, let's write that, working times 0.12 is 0.0924. All we then want to do to get the total probability of either of those things is to add those probabilities together. So add 0.207 to that value, and we get 0.2994. There we go. I've not been told to round it. That's the whole answer. So I'm just going to put all of that on the answer line. 0.2994 is your total probability that she would be late on exactly one of the 2 days. Question number 9. Here is a trapezium and a circle. The area of the trapezium is equal to the area of the circle. Work out the diameter of the circle. Give your answer to 3 significant figures. So the area of a trapezium, there is a formula in the front of your exam this year. So it's half A plus B multiplied by the height. I prefer to think of it though as A plus B divided by 2 times by the height. Now that is exactly the same thing, but the reason I think of it like this is because for me, when you're working out the area of a trapezium, it makes sense if you're averaging A and B. So A and B are your 2 different widths. So we're saying that it's going to be 5 add 12 divided by 2. So we're averaging how wide it is, and once we've got that average, we times it by 7. So use the formula in the front if you forget, but if you'd rather think of it as an average times by the height, hopefully that might help you to make sense of it as well. So 5 add 12 is 17. 17 divided by 2 is going to be 8.5 times by 7, and 8.5 times 7 is 59.5. So we've got the area of the trapezium, 59.5, and we know that that is equal to the area of the circle. So 59.5 equals pi r squared. Now let's solve this. Let's divide both sides by pi. So 59.5 divided by pi gives us 18.9394 and so on, and that has to be our radius squared. So if we want to know what the radius is, we're going to square root that value. So again, I've not cleared it from my calculator. I'm doing the square root of that answer, and that is 4.35194. Again, I'm not going to clear it. That is not my final answer because we were asked not for the radius, but for the diameter. Now the radius goes from the middle of the circle to the edge, but the diameter goes all the way across. So the diameter is double. So to get the diameter here, we need to multiply that by 2, and that is 8.70389. Again, I just took the answer that was in my calculator and doubled it, and we're rounding this to 3 significant figures. So 1, 2, 3, check the next number, it's a 3, rounds down, so 8.70 is your answer there. Question number 10. Matt and Damien share 210 dice in the ratio 2 to 5. Now for ratio questions, I like to write them out 2 to 5 like that. We've got 210 dice to share over these piles, and in total we have 7 piles or 7 parts. So I'm going to start by doing 210 divided by 7, which is 30. So each of these piles has 30 on them. So to begin with, we can see that Matt on this side, Damien on this side, Matt has 60 and Damien has 150 to begin with. But Damien now gives some of the dice to Matt. And that means that Matt's going to go up, Damien's going to go down. And now they're in the ratio 2 to 3. But the number of dice hasn't changed. We've still got 210 dice. So I'm going to now take 210 and share it in the ratio 2 to 3. 210 divided by 5 is 42. So 42, 42, 42, 42, 42. So now we can see that Matt has 84 and 42 times 3, we can see that Damien has 126. So work out the percentage increase in the number of dice Matt has. Well, Matt's has gone from 60 to 84. When we are doing percentage change, increase or decrease, or even profit, it is the change, which in this case is 24, over the original times by 100. 24 over 60 times by 100. Typing that in your calculator, that gives you 40%. Question number 25. ABCDE is a pentagon. EDF is a straight line. Work out the size of angle BCD. You must show all your working. So this angle up here is what they're asking us for. First thing I'm going to do is fill in this angle here, because I know that angles on a straight line add up to 180. So 180 take away 48 is 132. So this angle here must be 132. And now I can just look, I've got 5 angles inside that pentagon, and see how much I'm missing. Angles in a triangle add up to 180. Angles in a quadrilateral add up to 360. And every time you add another side, you add another 180 degrees. So a pentagon, a 5-sided shape, adds up to 540. So let's add up what we've got inside the pentagon so far. 112, add 168, add 71, add 132. I'm just going to add that up on my calculator. You wouldn't include the 48 because it's not inside the pentagon, so that one would not contribute to the 540. 71, 112, add 168, add 132. There we go, 483. And we then know that they need to add up to 540. So 540 take away 483 is going to be 57 degrees. There we go. So X is 57 degrees. Great. Question number 26. If this question comes up, you do now have a calculator for this. And there's a couple of different ways you can do it. I am going to upload a video on how you use your calculator to do this. However, I think it's just as easy to use brackets. So in your calculator, I would take this, and every time you see an X, I want you to put brackets. So in your calculator, you're going to type bracket, bracket squared, minus 2, bracket, bracket, minus 1. That is then going to allow you to just change whatever numbers in the brackets to be each of these values here. Okay, so we're going to start by putting minus 2 in the brackets. Minus 2 squared, minus 2 lots of minus 2, take away 1. And that's going to give you a value of 7. You're then going to go back, left-hand arrow, and change what's in these brackets to be minus 1, the next value. So minus 1 squared, minus 2 lots of minus 1, minus 1. And that's going to give you your next value of 2. And repeating that process with a 0 and then a 1 and then a 2, we get minus 1, minus 2, and minus 1. Each of these is coordinates that we're going to plot on the grid. So minus 2, 7 is up here, minus 1, 2. We've then got 0, minus 1, 1, minus 2, and 2, minus 1. This is a quadratic graph, so we're going to draw it with a nice smooth curve like that, and back up here, and it would continue on, but we don't need to go beyond that. That's all we've been asked to draw. Okay, then it says, using your graph, find estimates for the solutions of the equation x squared minus 2x minus 1. Well, that's what we've just drawn. equals minus 1.4. So when does your quadratic graph equal minus 1.4? Well, minus 1.4 is here. 2 little squares below minus 1 because each of the squares is 0.2. And then we just need to look and see where that crosses the x-axis. So I've got there and I've got there. Now I think for this I would accept a small range, let's say from 0.1 to 0.3, and for here let's say I would accept from 1.7 to 1.9. I've ended up in the middle of those, so let's go 0.2 and 1.8 would be my answers there. Don't write them as coordinates. We're not looking for coordinates unless it says coordinates. It's just saying what value of x would solve this equation, and so we're giving the two x values, 0.2 and 1.8. You could put or if you liked, but don't write it as a coordinate. That's a really common mistake. And last but not least, question number 27. So make t the subject of h equals 7t add 2. So just like when we solved the equation, we're going to use a dotted line here, and what we do to one side, we're going to do to the other. To make t the subject, I need to get that t on its own and everything else on the other side. At the minute, h is the subject, but I want t to be the letter that's on its own. I'm going to start by taking 2 away from both sides. That's going to get rid of the plus 2. So on the left-hand side, I've got h, take away 2, equals 7t, and then I don't want 7 lots of t, I just want 1 lot of t. So I need to divide this side by 7 and divide this side by 7, and to write that it's going to be h take away 2 all divided by 7 equals t, and you can flip it around for the answer line but you don't have to. H minus 2 all divided by 7, and now t is the subject of the formula because t is on its own and everything else is on the other side. For part B, work out the value of y when x is 4, and we've got this here. So we know that y is 3 lots of x squared take away 5, and we're going to put in when x is 4. So 3 lots of 4 squared take away 5. Now we're going to do the indice first before we multiply. Think of BIDMAS, we do the indices first. So 3 lots of 16 take away 5. 3 lots of 16 is 48, and 48 take away 5 would give us a final answer of 43. There we go. That's all 80 marks of the paper. I hope you found it helpful. Good luck, guys, with paper 2. Please feel free to join me. I'm doing a revision session on the 31st for 3 hours. I'd love to see you there. You can sign up on my website, hannahkettlemaths.co.uk. But yeah, all the best, good luck, and I hope to hear from you guys in the comments with how you found this paper and how you found the exam. Good luck, guys.